Okay, so you're going to have to bear with me on this tutorial a little bit. This is tutorial 20, and it's a bit experimental, so it might be a love it or hate it tutorial. And hopefully more of you love it than hate it. So what this is going to be, as you can see from the title, it's a breakdown of Urban Santa, which is Big Toe Interactive's second game. It's the last game we made. And, whoa, let me turn that sound down. The purpose of this is not so much to focus on copying the code and taking my assets and trying to use them. It's more about understanding the basics, the structure in this first tutorial of how the game works, how a simple game like this, a level-based, fixed screen type of shooter action game works. So you can go to Newgrounds, the link is there on all my video tutorials, the link to play this game, so you kind of understand what you're building towards and how it works. It's moving a little slow now because of my video capture program. But for anyone that hasn't played it, this is the basics of the game. You move with the arrow keys up and down and left and right, fire presents. And you're playing as Santa to the kids, you're delivering the presents. So it's a really simple game, but it's a great kind of foundation to build bigger games upon. The game gets more complex as you go on, and I won't go into too much detail, but you got to go to that Newgrounds link and try the game at least for a minute or two to just understand what this series of tutorials, I'm hoping to do 2 or 3, however many it takes to kind of break down the important parts of how this game functions under the hood. So that's the basics of it. It's very simple, and let's get into it. So in this first one, we're just kind of going to go over the structure of the game. We'll get more into the characters and all that later on. Okay, so the start game function is kind of where it all begins here. There's a couple of other things before that that load the preloader and load the menus, but the start game function is what gets called when you're right here in the game and you load the level. That's where the real game starts, so that's the logical place to start. And we're going to look at these 5 functions. I'm going to kind of skip this one for now because it just resets the properties that you haven't seen yet, which there's no point in doing before the game's even been played. This is for every level after the first. But anyway, you set the level properties, which we're going to look at first, add the buildings, add the windows, and add the interface. Before you can add any visual elements, you've got to set up the properties for that level, which is a huge function, and by simply telling it what the current level is, of course now it's 1, we started at the beginning, you can adjust all the parameters of the game. And I'm proud of the way I built this. I don't do everything right. I certainly make a lot of mistakes as a programmer, but the greatness of this system, which I didn't invent, but I implemented, is that you can so easily test, balance, and tweak the game by changing a couple of quick parameters. And by the way, most of these parameters are just integers, strings, or a timer, something really simple that I'm sure you know what they are. So let's look at what's happening in level 1. What are the initial properties that set up level 1? And you can apply this to any game that's level-based like this, especially with a fixed screen, and like an Angry Birds type game, a puzzle game, a Bejeweled type game, or whatever it may be. If you're setting up boards and you have a game that's at all like this, you can use this same structure that I'm showing you, and that's the point of these tutorials that I'm doing now. So we start the Catch Kid timer. All the characters in the game, these girls that catch the presents being one of them, all the ones except Santa and Mrs. Santa, have timers that control how often they pop up in the windows. So this particular one, we're starting the catch kid, this girl that catches the presents, we're starting her timer. We're setting the number of floors, which is an integer variable in the document class, to 3. We're setting the number of kids left, which is this number here that goes down as you give them presents, setting that to 5. And we're saying, now that we've started the kids timer, we're saying the delay should be 3,000, meaning every 3 seconds a new kid will pop up in an empty window. And the program knows which windows are empty and which ones are filled, which you'll see at some point in this tutorial, the next one. So that's all that's happening. Set up the initial properties. As the game goes on, I'll show you later, you get more of this. You've got timers for 4 different types of characters. There's more floors. There's more kids. It's more complicated. There's also some, power-up type things that get added later. But for now, it's really simple. So let's look at going down our list. Bear with me, I'm trying to stay organized here. Let's go to the next function that was important in our start game function, which is the add buildings. And all these three below are related to visual elements in the level, that are in every level. So these 2 buildings here, of course there's 2 of them and they have 3 floors for now, but the number of floors goes up through the game to 5 in this version of the game, 7 in the iPad version. So based on our number floors property, which we just saw where we set it to 3 in the first level, we can tell this building model, this building drawing, to show you here is just a movie clip in the library. We can tell it how many floors to show. So there's 3, and it goes up to 5. We're just going to a different frame in the movie clip. It's that simple. We tell it where to go. That's the building. That's all you need to know about that. The next one, again, this was called in the function we were just looking at before. Right after the buildings, the windows is called add the windows. Loops and arrays. It's all about loops and arrays. That's like the most important thing to just utilize, as I've said a million times. So based on the number of floors, we go through and we essentially create a grid of windows. Loops and arrays, well, loops in particular, are great for creating grids that are exactly even. There's I think it's about 35, 40 pixels between the windows in each dimension, and that's handled by the grid. I just send it the starting position, and it adds a vertical and horizontal offset based on the starting window, which is one of these. The starting one, and it adds an offset to go there and to go up, and that's how it puts them all in. And it's just trial and error getting this right. It also sets a couple of the properties. I'm not going to get into specifics now, that'll be later on, but I store some properties about that particular window. Is it on the left side of the screen or the right side, for one? Is it in the middle, etc. So that happens. And then the last function that gets called, that we were looking at before, of those 5 originally that I highlighted before, is the add interface. And just like what it sounds like, this add interface function, which is called before every level is started, it adds all the visual elements you see, the heart box, the scores, the icons themselves, including the pause and mute button, and it even adds in Santa and Mrs. Santa, and it adds in Mrs. Santa based on, again, how many floors there are, because you can't appear, through the building. This building is higher, she's got to be up here. Same thing. It looks at that simple integer variable. I know I'm stressing that, but it's so important. When you have these global variables in your document class, you can access these. This game, by the way, is made up of about 40 different classes that all reference the document class. And at some point I'll have to show you kind of the big picture of how that works. But a simple integer, a simple Boolean variable, a simple string, you can do so many things by just referencing it in all your different classes. And I'm trying to show you how that's sort of done. So we set up all these elements. We add Miss Santa and we add Santa to the screen, and that's it in the start game function. So let's go back to that and let's see where that leaves us off, which I believe the next thing to look at is just our loop and kind of break down you want to call it the engine of the game, which is going to take a while to break down. The 5 functions we just looked at, we didn't look at this one, but all it does is set the properties back to the way they were. It resets the score, resets the lives, all that, resets things. You're gonna have to bear with me throughout these next couple tutorials. We're gonna have to ignore certain blocks of code because it's not important to what we're talking about right now. The black box is just the transition that you see in the screen. Set the hero position. What's important here is after all that it's done that we just saw, we get to the loop. We get to everything that the main loop that you see in every game has this. I don't care what language it's written in. It has a main loop that everything feeds into. So in this game, we start our loop, and we also start a bunch of timers. And these aren't used in every level. It looks like a lot, and I know this isn't the exact best practice, so please defend me in the comments when an angry programmer starts attacking me. Why are you using so many timers? Well, it works for what I was doing, and these timers are not called every frame. But it is important to note, especially on mobile, you don't want to use too many timers or too many loops. You don't want too many things that are running every frame. But for me, the loop is the only thing that's running every frame, or enter frame loop. These timers go off usually not more than once a second. So that's 30 times slower than our loop, or at that frame rate. So the loop runs. Let's look at the loop, which is the next important thing. This loop here, which you can see that this is the engine of the game, and it's a 26-line function. Out of this document class has 4,000 lines. But this loop is the engine of the game. What it first does is check if the game was paused, if this pause button is pressed. You can't have things animating if it's paused, and I'll try to show you that if I can time it right. See that present stopped? When I press the pause button. It would look stupid, obviously, if it didn't. So the game's paused right now. It has to stop the animations, and it has to also remember how much time was passed while it was paused. I won't go into detail on that, more detail than I already did. Whoops. But that's what it's doing here. And other than that, it does all these functions. And this is the engine of the game right here. This actually, forget about that. I don't think that even does anything, honestly. I gotta take that out. But check Santa Y. It tracks where Santa's Y is, so I know where to draw the fishing line to connect it. You wouldn't have the fishing line going through him if he's up here, so it has to raise and lower depending on where he is. That's all that function does. It just checks his Y value. It's that simple, and displays the graphic accordingly. And the animations are handled separately. Check character. This is a big function, so let's look at this here. It's a complicated one too, and I'm not going to go into it in extreme detail. But this, as it says in my note, it checks if any characters should be removed from the windows, and I think it might do something else too. But so it's important to note that all the elements of the game are stored in arrays. And I'm going to digress for a second, and I'm going to show you that at the top, that everything is stored in an array, loops and arrays. the windows, the presents, the enemies, the kids that catch the windows and throw power-ups, the weapons, and the power-ups themselves are all in arrays. So let's go back. I think it was right around here. Check character. Where was it? Check character. I lost it. There it is. Okay, check character. So this function, it checks who needs to be removed from the windows and kind of what to do with them. So it's looping through. Let's kind of look at it from a big picture first. It's looping through the enemies array first. That's what all this is, a for loop for the enemies. It's looping through the kids array next. That's what all of that is. And a lot of this is the same code, well, similar code, but changed to different arrays. And it does a couple of other things. For checking whether the level was B and then the windows are cleared, it's kind of for playing an animation. But the important part is this function, just like what it's named, it checks all the characters to see what state they're in and what needs to be done because of that. So first here, looping through the enemies. And I use a simple property, a simple Boolean property, true or false, to see whether the enemy needs to be removed. And I'll show you for the kids, since there's no enemies in this first level, you just have to watch as I talk. So I don't want to stop here, but there they go. After a while, they'll go away. They're set to appear and disappear at a set time. So once their timer goes off, I tell them I change remove to true. And so this function just checks the character, it looks through all of them in the array, and if remove is true, it cues their animation to visually take them out of the windows, and then it actually removes them from the array. But in the process of doing that, it has to also adjust the window itself. And again, I won't go into too much detail on that because this is specifics, but mainly what's important to note is it has to keep track of which window this enemy was in, and now change the filled property of that window to false. So the game doesn't think there's still a character there. It knows that window is empty now, so we can, if we need to, all the characters are put into windows randomly most of the time in most levels, but the engine needs to know that window is now empty. So window.w looping through, remember, that window that we're talking about right now, which is the one the enemy was just removed in, the filled property is now false, so it's empty. And the same thing that you're used to. Once this happens, we remove that enemy from the array. We reset the properties on that enemy to have it be ready. And the reason we reset that properties, we have to reset the properties on them, which is a topic you should look at further, and maybe I'll do a whole tutorial on, is object pooling. All the enemies, bullets, power-ups, and the good guys, everything except sand, all the things that there are multiples of in the game are put into a pool. And this is very important, especially on mobile devices when you have a set amount of memory, to use an object pool rather than just creating and destroying all the time. You have a set amount of objects in the pool, and you take them out of the pool and you put them back in the pool is the basic concept. And I should probably do a whole tutorial on that. But you want to look into object pooling and learn of it. And it's all about putting something in the pool and taking it out, and maintaining that pool of objects. That's what it's all about. So that's what's happening here. So that's it for that. Then it does the same thing with the kids array. Whether it was a kid or an enemy that needs to be removed, same thing. Finds what window they were in, tells it that the window is now empty. And by the way, the window gets told that it's filled when a character is added, which you'll see later on. So that's this function. That's all it really does. It does something special at the end because it has to cue the animation. It just looks at whether there's no more kids left for you to catch presents to, which I'll kind of show you right now. There you go. When you beat the level, it cues them to fill the windows, clear the projectiles, and fill the windows for that victory screen at the end. So this is the second level, and they add more cups. So that's all that does. Now let's go back to our loop and look at the next function in the loop. That was a big one. A lot of these are, other than the check collisions one, which is huge, a lot of these are going to go quicker. Whoops. These three functions, move hero bullets, move enemy bullets, and move the kids' bullets, which are the power-ups that the kids will throw you. They're all very, very similar. They're just dealing with different arrays. The move hero bullets obviously is dealing with Santa's presents. It looks if the level beat another Boolean global variable. Was the level beat or not? True or false? If the level was beat, there's no sense in running this code. So if level beats true, return. If not, it loops through the presence array, which again, the presence array is made up of all on-screen presents. And it simply moves them, and then, of course, also looks if they've moved off-screen. So it's moving them, by the way, in the direction. Presents can be bounced later on. So you've got moves them to the right, moves them to the left, or down and right, or down and left. Later on, they get bounced on these SWAT shields, which is pretty cool. So I suggest you play far enough into the game to see that, because it's one of the best characters in the game. And other than moving them, it detects if they're moved off screen, and if they are, it removes them from the screen and from the array, just like everything else. The enemies is the same thing, although for the enemies, not only do you have all this movement, you also have to know what type of weapon it is. So we have a baton in this level. As you'll see, the enemies throw a baton. Later on, there's a laser gun from the SWAT guy, which does 2 points of damage, I believe. So that's why we need to know which one does what, and also how fast to move it, since it moves at a different speed than the baton. So that's what this function does. It moves the enemy projectiles that you're seeing right there. And the last one is the same thing with the kids. I'm not going to go into it again. It just governs the kids will throw cookies and milk to Santa, which are both health and a power-up, respectively. So this keeps track of that. It moves them, and it sees if they went off screen, and da-da-da. So that's those three. Now I'm going to go right into the check collisions function, which is huge, and bear with me because it's going to be complicated to talk about. I'll try to tell you what you need to know. But as you can imagine, it does a lot of what it sounds like. It checks for collisions between a few different things. It checks for collisions between the presents and the kids, like you just saw. It checks for collisions between the baton and Santa to know whether he's gotten hurt and whether he's now dead or not. Like there, he's blinking. The check collision told me to blink when I got hit, and it also lowered my hearts, of course. So it does that, and it checks for power-ups. It checks for all the different collisions that could happen are all handled here. There's some complicated stuff going on here, mainly because I use a more complicated version of hit detection than the one I showed you in tutorial 7, I think it was, that deals with hit test object rather than I'm sorry, not hit test object. That's the simple one. It deals with bitmap data and the hit test function instead of hit test object, which is, remember, deals with the bounding box. This deals with the actual pixel level hit detection. So it's much more expensive on the processor to do. So you have to kind of use it only when you need to. But anyway, it's pixel level hit detection. So it's complicated. I'm not going to go over it. You just look up bitmap data hit test, and you'll get all this information on it. And it does the same thing. It checks the presence and the enemies. It checks the presence and the kids, because it has to know there are enemies that catch the presence. So it's just a nested loop, like you saw in my last tutorial series in the shooting game. It's 2 loops, one nested. It checks if any of the enemies have caught any of the presence. Then this next loop here checks if the kids have caught the presence. And this next loop checks if any of the weapons have touched the enemies. And this is used for a couple of reasons. I'm not going to go into completely, but the SWAT guys that bounce the batons, the enemies can bounce the projectiles that hit other enemies. They also bounce the presence, which is probably going to be another one here. So and also they check if Santa's getting hit. So there's all these different, but it's all just a series of loops that when it detects a hit, it just adjusts. It adjusts something. It adjusts Santa's health. It adjusts the score. It adjusts the number of kids that are left in the level. It makes it bounce. It's just a series of loops, looping through arrays, detecting hits. That's kind of what's important to all that. I know it's really simplifying it, but that's what's important to understand. It also has a power-ups one. So that's the check. That's the check collisions function in kind of a really broad scale. You can see how big this function is. And it checks for a couple of other things other than collisions. It checks to see we have cookies that give Santa health. It checks to see if Santa's been tied up by the enemy so he can't catch the cookie. It checks to see if Santa has the milk power-up active when he's been hit, meaning he shouldn't take damage from that hit because he has the power-up that makes him invincible. It does all that. And it plays some sounds, depending on the collision. Sound effect 4, play the grab sound. So that's it. So let's go back to our loop, and I believe there's 1 or 2 more functions that are called in the loop. Yeah, the check lives. These are all things that can end the game, so it's important for them to be checked all the time. Why is it not taking me to that function? There we go. Oh, because there was a space there. Check lives function. You can see that this is actually a pretty big function. And it's the same thing. It's just looking at a few different variables that could affect whether the game should end, whether you win or lost. Is the level beat true again? Return. If the player dies, if hearts is equal or less to 0, and you're not in a mini game, the mini game you can't is different. So if the player dies, stop the loop, remove the interface, stop the characters, pause everything. It does all these things. Check how much lives. If you die in the mini game, you have to play the game to understand what that means. It's all these situations. If you beat the level, meaning if the number of kids left is 0, then you do this. Level beat equals true. Save the score. Again, the same little things though that it's important to do. So that's kind of the last thing in the loop. There's something else that sets the score that I'm not going to show you, but kind of the last thing that's important is resetting everything back. So again, when the level ends, we stop all the characters' timers from running. That one's kind of self-explanatory, but I'll go to it anyway. We stop all the timers. We remove the listener for that timer. And you might have saw this one before. We pause the projectiles. When you beat the level, the presence will stop moving, as will the enemies. Pause any animating projectiles. This is another thing for performance and also so it doesn't look stupid when you beat the level and there's things still moving. You loop through the presence and you loop through the weapons and you call a function on those objects themselves, on their classes, that pauses them. I'm going to go into detail on this stuff in another tutorial, maybe the next one. But it's just important to understand all this, how it all fits together. This pauses the projectiles, and this pauses everything. So let me find the name of the function that's called when clear the interface, and here's the functions that kind of clean it up and get it ready to start over. There's like 3 or 4 of them here. Clear the interface. Okay, you can imagine what that does. Removes the interface and sets the interface cleared to true. Make sure it doesn't happen again. Clear the projectiles. We've already paused them, you just saw. Now let's clear them from the screen. Loop through the array, remove them, reset the properties on the present, and put them back in the pool. Then null them and splice them from the array. Same thing with the weapons, the power-ups, etc. Now that we've cleared the interface and the projectiles, we clear the screen, we stop the loop. This is also where we stop the engine from running. Then we remove, everything else has been removed, move their main characters. Remove the presence, remove the weapons, remove the power-ups, if the stuff already hasn't been done. Remove everything. Remove the windows. Set the screen cleared to true. And then we save stuff. You save the lives. This stuff is all called depending on whether the player beat the level or lost the level. There's a save system in the game, as you can see, that saves the score, and it's your lives transfer on to the next level and etc. And this is just that information, but excuse me. Oh, sorry about that. What's most important is, I don't want this tutorial to run too much longer, to give you that brief overview of that's how everything works. And now that you've kind of seen that and imagined that, let's see if I can find that reset properties function. There we go, reset game properties. Now that you kind of understand starting over, here we go. This is kind of an overarching reset, as it's called. Level beat equals false. Since this is called, again, in the start game function, right before we do all those things that I just showed you at the beginning of the tutorial, you have to reset everything to make sure you're starting it as if the game had first loaded, as if it was brand new, nothing is remembered from the level before, other than the score and the lives, which are the only things that carry over. And of course, what levels are locked and unlocked in the level screen. Those are the only things that carry over. The scores, how many stars you got, etc. Set the level beat to false. Set the current score to 0 because that's dealing with every level has its own score. The score is not, it's just stored. It's not, doesn't add up for each level. Every level has its own score. The current hits, all windows filled, false. Of course, all the windows aren't filled, so you have to reset that. All windows are empty, true. The levels just started, they're all empty. The hearts are back up to the max hearts, which is 3. It's just loading all these things. The hearts are back, score 0. It's reading all these things. The game is not paused when it's first started. The victory box is not on the screen. The victory box comes up when you beat it. Santa, which direction Santa's facing, which is always right in the beginning. He starts on the first floor. He's not tied up. These are like interface power-up things. But the point is, you're resetting everything back to the way it is. And you're resetting the properties on the hero. I'm going to go into this on the other tutorial. In the next one, I'm going to get into the specifics of all the characters and projectiles in the game and how this all fits together, which is going to be probably even more important and more useful to you than this tutorial, is how the document class talks to all the other classes. How does it all communicate with each other, which is one of the most difficult things to get used to it in object-oriented programming. And as you're building fully fleshed out games, that's probably the most difficult thing in my opinion, other than dealing with the heavy math of physics type stuff, and that stuff's beyond me, a lot of it. But other than that, the most complicated and the most rewarding when you get right is how it all talks to each other. How does the document class communicate with the hero, with the presence projectiles, with the enemy projectiles, with the power-up projectiles, with the score system, with the live system. How does it all communicate together? And as I said, this game is made up of 40 different classes, which I'm just going to show you real quick now before I end this tutorial. The beer, it's not actually beer, but that was just a thing. All these are classes. The document class is just one, but all these AS files, this is Urban Santa. There's about 40 of them, I'm guessing. And they almost all of them talk to the document class, of course, but some of them talk to 3 or 4 different classes as well. And that's kind of where the meat of things is. Other than looking at the basic engine like we did, you really need to understand that, and you're going to get so much better as a programmer once you're able to communicate and pass information between the different movie clips and classes that you're writing. This hero class I wrote from scratch. This is Santa. It's only 150 lines. It's not that big. This is a window. It's a tiny class. This is the girl that catches the presents. It's 130 lines. But they all have their own properties. A lot of them are similar. Anyway, I've gone on enough. I hope this was useful. Let me know in the comments. It's experimental. Thanks for watching. Please subscribe and send it to your friends. And check out Urban Santa at newgrounds.com, congregate.com. Thanks.